Hello, hello, hello. Welcome back. We're going to cover a little bit more for your understanding and benefit of parallel universes, the multi world theory, deja vu, Mandela effect, time loops, time travel, and even ghosts or apparitions who are dressed in period or different era type clothing. Okay. So I'm going to share my screen and we're going to look at some cool content with great visuals.
This video is sponsored by Blinkist. Until about 1900, all we had was classical mechanics. This is the mechanics of Isaac Newton and James Clerk Maxwell. But after 1900, Max Planck ushered in an era of quantum mechanics, and it explained the various anomalies in classical mechanics, such as why electrons do not radiate energy and fall into the nucleus, as they should according to Maxwell's equations. Since that time, quantum mechanics has become one of the most proven and successful theories in all of science. But while equations such as the Schrödinger equation are superb at making predictions and explaining behavior at quantum scales, when you start asking the question, what is actually going on? This is where the controversy starts. Caltech physicist Sean Carroll says, quantum physicists are like people with iPhones. They know how to use it and can do some great things with it, but if you ask them what's going on inside their iPhones, they have no idea. Similarly, he says, physicists know how to use the equations of quantum mechanics to predict all kinds of things, but ask them how quantum mechanics actually works, and if they're honest, they will say they really don't know. But this hasn't stopped physicists from speculating what the mechanism is. These various speculations are known as interpretations of quantum mechanics. The standard interpretation is called the Copenhagen interpretation because it was devised in Copenhagen, Denmark, by mainly Niels Bohr and Werner Heisenberg in the 1920s. This is the interpretation that's taught to most students in college, but even a majority of physicists don't agree that this is the correct interpretation. In fact, there is no single interpretation that has a consensus agreement. So, what is the Copenhagen interpretation? What are the best alternative interpretations? Why do we need interpretations to begin with? Those are some great questions which I will attempt to answer coming up right now. The primary challenge of understanding quantum mechanics is that according to the equations, all particles exist in a state of superposition. That is to say that the properties of any quantum particle, such as its position, momentum, spin, etc., is not only unknown, but is unknowable until it is measured. In fact, before it is measured, the particle is said to be in many states at once. It's not here or there, it is here and there at the same time. It's not spin up or spin down, it is spin up and spin down at the same time. This sounds crazy from our classical mechanics perspective because we never experience large objects being in superposition. When you hold a tennis ball, you know exactly where it is and how fast it's moving. So the quantum mechanical behavior predicted by quantum mechanics does not seem to fit with our worldview. One of the biggest challenges of quantum mechanics is trying to explain this transition from what is thought to be behavior of objects at quantum scale, superposition of multiple states, versus their classical behavior upon measurement. The various interpretations of quantum mechanics can be thought of as attempts to explain this transition. Most interpretations of quantum mechanics focus on the Schrödinger equation and the wave function to explain quantum behavior. This equation was developed by Irish-Austrian physicist Erwin Schrödinger in
Now,
1926.
just for a moment, I want to remind you how um, we've been taught through many examples that, like, if you keep the eye on the ball, you'll hit the ball, right? Odds of probability of something happening a certain way depends on the number of people that are observing said object, right? So if you've got 100 people watching someone getting ready to hit a baseball, And 82% or 82 of that 100 people want him to hit it, and he has his eye on the ball and he's focused, then the odds are for him that he will hit the ball. If you have more people looking at him and hoping that he misses, especially if he personally is not keeping his eye on the ball and staying focused, the odds of probability say he will not hit the ball. Same concept with bouncing the tennis ball and it coming back up to our hand, or anything else that we do, literally anything else that we do in life. Our willpower is actually our will, our focused thought, our intention is what is creating every single step, move, and action that's made in any given moment. I have used examples of this before in other video segments that I've done, where I spoke of a car wreck that was playing out before my eyes, that I was in a car right behind the car that was in the wreck with another car, and how me keeping my eye on the whole situation going on is how I was able to bob, weave, slow down, speed up, move over, do whatever I needed to do at any given second to evade being involved in the crash personally. We can control odds of probability with focused thought, collectively and individually. So just keep that in mind as we go through this, okay?
Contains a wave function represented by the Greek letter psi. German physicist Max Born formulated the interpretation of psi, which is that the square of the absolute value of psi represents the probability of finding a particle in any one particular state if we were to measure it. The concept of measurement was introduced to explain what we actually see when we make an observation. The fact is that even if it were possible for particles, we would never see them being in superposition. We would only observe them being in one state or another. We would only see the spin as up or down, not up and down. Presumably,
and that's 100% accurate on that. And also, the speed of time changes. And even Einstein wrote an equation on that, that the faster you go, the slower time is. And like we talk about that all the time with how time flies when we're having fun, or time will drag on when we're bored out of our gourd. Like, it's affected by action, and thought is an action. Thought is faster than the speed of light. So thought is what is creating your outcome.
Observation acts like a measurement that destroys the superposition. To give you an intuitive feel, let's look at some of the interpretations in terms of the famous Schrodinger's cat experiment. This is a thought experiment proposed by Erwin Schrödinger to illustrate, ironically, what he felt was the absurdity of assigning probabilities using his own equation. In his thought experiment, we have a box. There are 4 things in the box. There's a cat, a radioactive source. The emission of radiation is completely random according to most theories of quantum mechanics, so this is the source of the quantum mechanical randomness. There is a radiation detector attached to a hammer and a vial of poison gas like cyanide. If the detector detects radiation, the hammer comes down and it will smash the vial of gas and the cat will die. If it doesn't detect radiation, no gas is released and the cat will stay alive. If we look at this from the quantum mechanical point of view, there are 2 possibilities for the wave function of the system. If we presume that the quantum system consists of just the cat, prior to measurement, the wave function of the cat will look something like this, where the wave function describes the superposition of the cat being alive and dead. We have 1 over the square root of 2 because there are 2 probabilities, and the square of each probability will be 1/2, and thus added together, the total probabilities will be 1. The wave function always shows that the sum of all probabilities will equal 1. In the standard or Copenhagen interpretation, as soon as you open the box and make an observation, one of the probabilities comes true and the other probability disappears. So let's say you observe the cat being alive. That probability is not 100%, and the other probability of the cat being dead becomes 0. So that probability goes away. This is called wave function collapse, meaning the wave function has collapsed to one state based on the 50-50 probability. The wave function collapses as a result of the measurement made by an observer or apparatus external to the quantum system. A measurement is simply an interaction of the quantum system with a classical system. In this case, it is you, the observer, opening the box and measuring whether the cat is alive or dead. The problem with this interpretation is that it sets two sets of rules for how particles behave, one for before measurement and the other after measurement. But it doesn't explain how this transition happens. This is often characterized as the measurement problem. Why did the other probability go away? What is the mechanism that collapsed the wave function? Bohr might have said, well, it's just the data. The data is that we observe only one event, so all the other events that we could have observed no longer exist. We are just interpreting quantum mechanics based on the data that we can plainly see. Don't ask me how or why this happens. Or you can say what Richard Feynman says when asked the question, just shut up and calculate. This is just not very satisfying because we, and I won't speak for you, but at least I need to know what's really going on. A popular alternative, the many worlds interpretation of the same event, would be that no collapse occurs. The wave function is the only true nature of reality. It never goes away. This interpretation was formulated by Hugh Everett in 1957 as a graduate student at Princeton University. And the followers of this interpretation, sometimes referred to as Everettians, say that this is the simplest and most basic interpretation of quantum mechanics because it introduces no other assumptions or equations other than the Schrödinger equation. In our cat analogy, the distinction that the many worlds interpretation makes versus the Copenhagen interpretation is that it says, hey, you as the observer are also a quantum system, and you are entangled with the cat. So the wave function includes more than the cat. It also includes you, the observer. It would look more like this, where one part of the wave function is that the cat is alive and you observe it as such, and the other part where the cat is dead and you observe it dead. This is one wave function. When you open the box, the reality that you observe where the cat is alive is but one world. However, there is another world in which you would have found the cat to be dead. Both worlds where you found the cat alive and where you found the cat dead exist. You just happen to find yourself in one of them. So the question is, why do we find ourselves in the one branch where the cat is alive and not the other one? Everettians argue that the other version of ourselves in the other worlds are asking the same question. You just happen to be asking it in the world you find yourself in.
Or maybe you really just don't want to find the cat dead. And so that's how come it turns out that way for you. Power of thought is real. It manifests things.
The universe is equally real to those living in it. Now, to embrace this interpretation, you have to accept that many, perhaps infinite worlds exist, all with different quantum outcomes. The problem is that this doesn't fit with our experience because we have no inkling of the other versions of ourselves. Where are the other ones? If we really are entangled with the cat, then shouldn't some part of me feel like I saw the cat alive as well as dead? But this never happens. There is never a world where I see the cat both dead and alive, where half of me saw the cat alive and the other half saw the cat dead. So how does the split of the worlds
But is there ever
occur?
half of you that really feels like it should have been the other way around? And you wonder how that happened? And also, let's ponder this thought. If you have a dead cat in this life, but there's a living cat in another life, in another world, isn't that true of all things?
Everettians say that it's due to
And I'll even take it a step further. Is that how we can still communicate with past loved ones? Is that how they seem to still be present in our world at times? Maybe. Maybe being a psychic medium simply means that I can go beyond this parallel universe into another one to communicate with someone that you seek to understand and learn fuller from. Maybe.
Decoherence. So what the heck is decoherence? Quantum decoherence is the physical process that's used to describe how quantum states transition to the one state that we experience. The Copenhagen interpretation treats the wave function collapse as a fundamental process without explaining the details of how it happens. Decoherence attempts to explain what appears to be like wave function collapse, but in MWI speak, it is a splitting of worlds. No wave collapse actually occurs. If the universe was composed of just you and the cat and nothing else, then you and the cat would be in a coherent superposition. This would be represented by our original equation here. The key realization is that in reality, you have more than just you and the cat entangled. Both you and the cat will also be entangled with your environment because that is also a quantum system. So for example, the cat will be entangled with what's inside the box, atoms of air, photons of black body radiation, etc. All these objects will be entangled with the cat, and you will also be entangled with your environment. The environment inside the box for a cat that is alive will be different than the environment for a cat that is dead. Why? Because a dead cat's interaction with the air molecules and photons will be different, not only because its position will likely be different, but also other factors such as heat produced, etc. So psi now looks like this, where there is an added component of the cat and you being entangled with environment 1 in one case and environment 2 in the other case. These two environments are completely different. Because the entanglement with the environment now enters the picture, the coherent superposition between you and the cat is broken. The Schrödinger equation says that the two parts of the wave function above are perpendicular to each other, that have no connection to each other. This can be interpreted as two separate worlds. It's as if the universe splits into two realities. This is decoherence. Decoherence is another way of explaining how quantum superposition gets
And again,
lost.
I want to refresh your memory, all of you who are familiar with Dolores Cannon and how she speaks of how the world will split and we will create a new world. Star Children, creating a new world. So if they imitate everything after us that's a machine or a technology anyway, could that be what our colliders are all about? The Hadron Colliders? To create another world? Or a multitude of them? For whatever purpose. Hmm, you be the judge.
By interaction with the environment. You can also think of this as the quantum nature of the original two-component system leaking information into the environment due to its entanglement with the environment. I made another video about information leak using tennis balls if you want to check it out here. The problem is that since there is no overlap between the branching wave functions, no communication or connection between the worlds exist. So it's unclear whether we could ever verify whether other worlds exist. The only evidence is the mathematics of the Schrödinger equation. An experimental verification may not be possible. Now, if the idea of quantum superposition and randomness makes you uncomfortable, I want you to relax because there are completely deterministic interpretations as well. One is the de Broglie-Bohm or pilot wave theory, also known as Bohmian mechanics. Another fascinating theory I like is the objective collapse theory by Roger Penrose, who combines principles from general relativity with quantum mechanics. And these two, along with some other crazy interpretations, will be the subject of my next video. So stay tuned, you won't want to miss it. In the meantime, check out this great app. I tend to read a lot, but always wish that I could read more. If you're like me, you're gonna love Blinkist, today's sponsor, because what they do is condense the best nonfiction books into 15-minute summaries that you can either read or listen to podcast style. It's an app that you can download on your phone or other devices. Blinkist allows you to save time, money, and learn new things that the world's best nonfiction books have to offer, faster than just about any other way. Think about 15 minutes a day, you can read 30 books If I finish 2 books in a
Sorry, I
month
just feel
currently,
like
I
I need to
consider
let him do his props.
that an accomplishment. One of my favorite books summarized on Blinkist is Tribe of Mentors by Tim Ferriss, who's one of my favorite authors. He interviews some of the world's most collects their down-to-earth success advice for the rest of us mortals to hear.
Okay.
Blinkist has
Well, that's enough of that. I just wanted to, let him get his stuff out because we're using his material to understand this better anyway. So, got to give a fella his due up and comings and let him do his sponsors and all that too. And I'll be sure to put his video link in the description so that you can go check out more of his stuff because he's got some really great material where he can help you to understand this whole subject and more on a more tangible layman's terms kind of a way, right? Which is where I need you to be so that I can teach you how to hit the ground running with this newfound understanding of how to believe in you, love you unconditionally, be proud of you, be grateful for who you are, which is where you need to be for our new world to really make a difference. Until next time, be well and be blessed in love and light.